Agile Automation, Assessing Automation Alternatives. That's a lot of A's in the title. I was kind of hoping to be presenting first. Maybe they would do it alphabetically, but give you a brief overview of what I hope to accomplish, or what I hope to talk about today. Implementing automation on an agile development process, building an agile automation team, assessing tools for agile automation. I want to talk about testability as well, which isn't directly related. Well, it is related to agile automation, but testing in general. And throughout, I'll stop and talk about some key considerations for whatever topic we're on. And at the end, there'll be some time for questions and discussion. So the first, I want to start by talking about two different automation models. First one called the parallel automation model. And I struggled to find a picture that depicted what I considered the parallel automation model, but I found this one pretty amusing, and I think it is relevant to that topic. This guy's using 2 mice. It looks like 4 keyboards, 7 monitors, and I don't know if you in the back can tell, but he has a headset on, so he may also be talking to someone. And I don't know how many of you in the room try to work like this. I've probably done it before. Sometimes it feels good, but it's easy to make mistakes like this. And it's easy to fail at something when you're trying to do many things at once. So with respect to this image, as it references the parallel automation model, well, let me describe the model. So what we're talking about is doing test automation at the same time as you're doing development and manual testing. So having that all happen in the same sprint. And I'm going to go into it a little further, but I want you guys to think about the challenges and the benefits of this model. So if anyone's done or looked at automation work before, this image may be familiar to you. We have a product backlog. Features come out of that backlog. Prioritized features come out into a sprint. They're analyzed. Design work happens. Features are implemented, accepted, and hopefully deployed. This implementation would have to include the test automation. So that would have to happen in order to be within good agile practice. That test automation would have to be done, deployed, and running before the story would be accepted. So for any stories you've pulled in or any features you want to build, you need to have the automation completed to be using this model. And I'm not sure if you guys can see this in the back, but I'll go through it quickly. This is a little more fine-grained view of a workflow for a parallel automation model. So on the left side, we have a feature. On the left side, we have development activities. So planning, coding, unit tests. Coding and unit tests may happen in different order depending on how your development team works. And depending on your development team, the unit test part may not happen at all. At some point, they're going to deliver something, though. On the manual QA side, you have reviewing acceptance criteria, creating test cases, preparing an environment, getting ready to start testing that feature, and then once delivery happens, testing, acceptance, and done. When we add automation in, we're adding planning, testing, automation, the creation of the automation, and arguably testing the test automation, which sounds a little redundant, but it needs to happen. And that all has to happen in that testing block. That all has to come together before a story can be accepted. The requirements for implementing this model are, in my opinion, a team with a very strong agile process. So they have to be very good at doing agile with development and manual testing functioning well before you can even consider adding test automation into a current sprint. You have to have excellent inter-team communication. So that has to happen often, and you have to really take advantage of the fact that things that are changing are going to affect the test automation team or resources as much as they are the manual team. So that communication has to go back and forth, and everyone has to be up to speed on exactly what the feature is going to look like. It's also going to require a very skilled test automation engineer or engineers, because they're going to be creating automation for something that doesn't exist yet. If they're going to get some work done ahead of the feature being delivered, they're going to have to both understand very well what that feature is going to do and have a great approach to build automation to work with that feature. Advantages are that there's little or no technical debt incurred moving from sprint to sprint. So you finish a story, the manual tests are complete, the automation is in place, the story's been accepted, you move on. And it's got very strict adherence to the Agile methodology where you're not incurring technical debt. The disadvantages or the challenges are that it puts a tremendous amount of pressure on both developers and automation engineers to be in sync on exactly what's delivered. The manual team can adjust for slight variations more quickly than the automation team can, because the automation team will have to deal with code change in order to make their automation work with what's delivered. And invariably, you're going to fail more often in that regard. So a story will get delivered by development, go through manual testing, and pass, but the automation may fail, because it may work exactly as it's supposed to, but if it doesn't deliver key features that the automation team needs, then it will still fail on that regard. The next model is the interval automation model. And that's pretty straightforward. In the track above, the development and manual testing team are working on the current sprint. In the track below, there's an automation team working one or more than one sprint behind, okay? This capitalizes on a number of opportunities, but chiefly among them is that the features that you're getting to automate are done. They've been tested, everyone understands how they work, and you're dealing with something that's a lot more stable than trying to build automation for something that might not yet exist. So what that looks like in practice is in the workflow above, it's a typical Agile workflow. Prioritized features that are completed then get moved into an automation backlog. They're prioritized again and then pulled into a sprint where the automated tests are developed.
Question about that.
Absolutely.
You still have deployed on the top circle with the prioritized feature. Would deployment not, or I guess the release not happen until after the automated test?
Well, that's a good question. I think that since the feature's been manually tested, that it's okay to release it. The automation is going to come in after the fact,
Okay.
and it's going to save you from having to redo that manual effort. So, good question. Thank you for that. Would you be able to deploy the feature given the fact that the automation hasn't been built yet? And did you guys hear the answer okay? Okay. Another question?
I have a question. You talked about failure being more common with the first method. Actually, it's a two-part question. First, how has the reaction been about that failure that has happened? Like, how do you explain it or get it accepted? And then secondly, are your people doing automation the same as your manual testers, or is this a different person in these?
Thank you. So I'll address the second part first. What I'm talking about is basically a second team, but you could use the same team depending on when in your Agile cycle development traditionally delivers. You could have the same team working on the prior sprint's automation while they're waiting for new features to be delivered. On your first question, reaction to failure, it's going to change depending on the organization, but depending on your product manager and how he feels about the automation, how necessary he feels it is, that story might get accepted anyway. Yes?
Sorry, I'm going to back up just a second. Automation, automated test sets is my swap. So when you're talking about automated tests here, can you give like a 25 words or less what you really mean by that?
Sure. I don't know that I'll be able to count the words, but when I'm talking about test automation, I'm talking about unit tests, okay? Integration tests, tests that work between systems without a GUI, and functional automation that's interacting with the GUI to validate some functionality. Does that answer?
Yeah, that's great.
Thank you for that. And guys, if there's any questions or clarifications needed, please just do what they just did.
There's different prioritization between feature and test, where you do manual and automation. It should be both of them, but why you are separating?
The prioritization?
Yeah.
I guess because you could end up in a situation where a story from an earlier sprint was important, but not important enough in that sprint for automation. So if you're working on high priority features in sprint 6 and some really lower priority features in sprint 7, you may want to automate more from sprint 6 than sprint 7. So it gives you the opportunity to reprioritize what's in the automation backlog.
Is one is behind because of that?
Yeah, one or more sprints behind. So
minimum.
yeah. Any other questions? Yep.
How do you sign off on your acceptance criteria then if you're one sprint behind in automation and that's not testing your regression?
Yeah, so it's separate. So you'd have acceptance criteria for the automated test as well. So in the sprint, the development and manual testing sprint, there would not be a requirement for acceptance criteria for automation.
But it might be acceptance criteria for your regression.
Right, but you could run regression without running automation.
Right?
You could run regression without automation.
You could. It might take you more than, like we have quite complex product. If I do it manually, it's going to take 5 days.
Right. So you would want, I mean, you're going to want to automate that. It's just not required for that feature to be accepted in that sprint.
Yeah, so you would move that acceptance of that feature to the next sprint?
Well, it'd be a separate sprint. So you'd have an automation sprint running one sprint behind, essentially, or one or more sprints behind. So it's a separate process. There's another team doing automation work based on the work that's done by the manual and development team.
I get what you're saying. I just think it's trying to apply to what we do is a little bit, it cannot be done that way.
Well, maybe we can talk a little bit more after. A closer look at the workflow for automation. You have an automation story in that separate sprint, planning, coding, testing, delivery, and acceptance. So that's happening completely independently of the manual testing and development sprint. They're obviously going to be working together, but in terms of the work being done, they're in separate streams. So for interval automation, the requirements are excellent acceptance criteria and concise test cases. And that's because you're not working directly in the same sprint as the the developers and the manual testers. So you're going to be more dependent upon the information that they're recording for you to look at later. The benefits, features that have been built and manually tested are less subject to change, right? They're already working, supposedly. Bugs have already been found and fixed, or at least you know about them and can avoid them. For the purposes of automation, you may actually want to write tests for them, but you know they'll fail. Little or no dependency on development. And I'd say no dependency on development might be a stretch. There's certainly less. That can also be a negative. Because you're not working as closely with development, you have less access to them, potentially. So if you need a change made in this model, you would have to go through a process where that change request or that feature would go back into a product backlog and get prioritized, and it may take a long time for it to make its way into the product, whereas if you're in the parallel model, that could happen in the same sprint quite easily. And the biggest disadvantage here is that you're incurring technical debt. So you can't just run the automation and know that it's tested everything up to date. It's going to be some degree behind.
Question on the last slide. Can you elaborate a little bit on what is an automation story?
Yeah, I guess it's a story that's going to talk about what you need to do to automate that feature. So taking a manual test case, looking at it, understanding what it means, and creating automation to fulfill that test case.
Okay, so it has its own acceptance criteria.
Yeah, so I like to look at it as it's another story, the same as a development story, only it's for automating a test. Yes?
I understand that you are talking about developing the automation. So where if the feature is executing the regression test all the time and analyzing and everything, because I understand that this is, the team is focusing on developing new tests and new test after new test after new test. They are created to be executed for the regression. So whose responsibility is to execute the test and monitor the results?
That's a good question. So if you have a continuous integration system, as tests are delivered, they're going to be put into the test runs that happen on a nightly or weekly basis, depending on how you're scheduling those. Test results would be distributed to all stakeholders, right? So anyone that wants to see what happened in last night's automation run or last week's automation run should get the results and be able to look at them.
So you think this is the responsibility of the developers who are interested to see the results and then go and fix, or it is the responsibility that, like, somebody has to take ownership of these things, not it's available for everyone who can look at it?
So who should run it? I think that ideally it should be part of a build, test, deploy process so that your automation, like your unit tests are run during a build. There's an automatic deployment of your software into an environment. Then this test automation gets executed and everyone gets the results, right? So who runs it? It should be run automatically.
No, I understand this, but who's looking at the result and who has the responsibility to analyze the results and say, oh, you have a problem here, there is a defect?
That's a good question, and to be honest with you, in different client implementations, different people do it different ways, and often it becomes a point of contention. Because you may have a manual test team that is definitely interested in the results, but may or may not have the ability to debug a result, right? If they get a negative result, they may not understand exactly what that is based on what they're seeing in the log or what the result says. The automation team is more apt to be able to have a look at those results, interpret them, understand where something broke or where something changed. So the best model I've seen is when manual and test and the automated team both take a look at that. You're welcome. So some key considerations in choosing which one of these models. Is there a way for you to automate this feature before you actually have it? Depending on the technology you have, there may be no way. So if you're trying to automate something that's flash-based or image-based, that may be extremely difficult to do anything with the automation until you have a product or a feature in front of you. If it's something that's based in HTML, you may be able to work with the developer to understand exactly how he's going to tag that element so that you can find it and interact with it. Will the feature stability affect the effort required? So does your development team always deliver stuff that works, or is there a high percentage of time that they deliver things that work? Or are they as specified? If there's a low probability of that happening, then that should affect your choice in terms of which model you adopt. And if I need changes to facilitate the automation, if I need them to make small changes to the code to make it easier for me to test or make it easier for me to automate, what's my level of accessibility and what's their tolerance for that? Are they willing to listen to that? Is it a consideration at all for them? Or are your requests going to fall on deaf ears? And with respect to the test cases, what sort of test cases is the manual team developing? And do they understand what you need or what kind of test cases lend themselves to automation? And I can expand upon that a little bit. Test cases for automation should be very concise and have one specific goal. So if you have a 45-step test case that tests 12 different things and 5 of them are high priority, if that's all in one automated test and that test fails, you really don't know what failed until you dig into the results. But if you have a very small, concise test that tests something specific, then you can know exactly what failed when you're looking at those automation results without having to search through logs to figure out exactly where it went wrong. Another consideration is automation for maximum efficiency. How many of you have looked at unit tests? Now, how many of you consider unit tests when you're talking about your test coverage? Okay, so actually that's pretty good. So in Agile teams I work with, I find that unit tests tend to be a black box. There's something going on there, they say they're testing it, we're not really sure what they're doing. And what I've seen is that there's a tendency with automation to redo a test that's already covered by the unit test. So you really need to understand, does the unit test actually cover what the test case needs it to cover? Is it a good example of a test case? Will it reveal regression in that functionality? If it does, that's fantastic. Or if you can get it implemented at that stage, then that's probably where it should be. The next place you should look is integration testing. Can we do something sort of one layer beneath the covers to validate this functionality? And then finally, functional automation, which for the purposes of this is automation that will mimic a user's activity. The reason that you should look at them in that order is because as you move from unit test to integration test to functional automation, the effort involved to create and sustain that automation goes up. It goes up very quickly. It's a very steep curve. So what might be able to be handled in a unit test, maybe consider that 1 unit of work, and integration automation maybe 10, and functional automation maybe 100 units of work. In order to do that effectively, you need to understand your software. You need to understand what components are interacting with each other. So if you know where some validation occurs, if you know that it's occurring in JavaScript on the browser side, then you know that you probably need functional automation to ensure that that's working correctly. If you know that it's happening in PHP code on the server, then you can bypass the client-side automation and just fire a message directly at the web server with the parameters you need and monitor the response for the correct error messages. And understanding the test case. Understanding what you need to do to achieve that primary objective of the test case. And what the least expensive way of doing that is. Any questions on that? Good. So we're going to talk a little bit about building an automation team and how to structure that. The first consideration is internal resources, external resources, or some blend. With internal resources, basically, you need team members that have both the ability and a passion for doing this kind of work. Some of the benefits are, if you're taking an existing tester and getting them to do automation work, they may already be a subject matter expert on your product. Other advantages are that it creates new opportunities for the team members, and the automation knowledge, the understanding of how it works, stays in-house. Some of the disadvantages, it's difficult to scale your automation efforts with internal resources. Basically, if you have to go and hire a FTE every time the workload increases, that process in itself can take time. There's training costs involved, and there's also potentially variable resource requirements. Your automation effort may not always be static. Option 2 would be an external automation team. You need to have the availability of a vendor or a set of individual contractors, and you need budget, right? You need to get approval to go over and do that. You need budget in either case, but the budget may be substantially higher in this case. The advantages, an external team is a lot more scalable. You're probably, well, you should be getting a subject matter expert in both automation and the automation software that they're using. The vendor may also be delivering with the resources, a framework or accelerators that they have developed over time that will help you get started more quickly. And you're going to get a broader knowledge base, right? You're going to have an automation expert who has done this in many different teams and solved different problems. So they may be able to apply those patterns with you. Disadvantages, you end up with a dependency upon external resources, right? So if you're dependent upon a vendor to do your automation, to run it, if they're looking after every aspect of it, then it's really hard to get rid of that vendor because your automation is going to stop and you're going to have to do a lot of work to get back up to speed on that. And to the same point, you really don't know any more about automation than you did before you brought that vendor in, potentially. So key consideration here is the variable resource requirements. The green on the graph indicates the actual requirements fulfilled by an external automation team. So you're ramping up and down resources as they're needed. The blue is what would be required for an internal team to do the same. So there may not always be enough automation work for that team if you have to staff it for the peak automation requirements. And you can get automation resources to do all kinds of other things, but that's not necessarily a best practice. The reason that it's variable is new versions of software require a lot more effort than maintenance releases. New features, same thing, require a lot more effort to automate because they're doing it with something new. Whereas if it's automating a defect found in an existing feature, there's probably existing infrastructure there to automate. Another reason is hardening sprints and spikes offer little opportunity for automation. The hybrid model, it allows you to be scalable up and down. It leverages both automation and product subject matter experts. It gives you access, potentially, to accelerators and framework from a vendor. You still have access to a broad spectrum of automation knowledge. And one of the key points here is that you're retaining automation knowledge. There's someone within your organization that understands how it all works, how it's all put together, and can maintain it if you decide to change vendors or you need to scale down. And this graph shows the hybrid model where you have internal resources and you're adding external resources to fulfill requirements as needed. Another consideration for the automation team is where they're located. Co-location, for anyone that doesn't know that term, is a group of people who are located in the same space. And anyone who's worked that way knows that you probably have a much lower cost of communication and a much higher frequency, right? So if I'm in the next cubicle to a developer and I hear him talking about how he's about to change a feature, then I've just received information about what I need to do to automate that feature. I can pop up and ask a couple of questions, and we're both still on the same page. That's not going to happen if your developer is sitting in Vancouver and your automation resource is in Bangalore. This is suitable for either parallel or the interval model. In terms of disadvantages, the cost, right? Sometimes it is more expensive to have everyone co-located and to find resources that are available that can be co-located. and it limits potentially your number of resource options. Now, that may not be as big a factor in Vancouver, where there's a large market, but in a city like Moncton, where I'm from, if I need to find someone who's an expert in automating API calls to SAP, I may struggle with that. So a distributed team, they're connected virtually, but not in the same physical location. Potential lower overall cost if you are able to use resources from an area where they're not as expensive. You may benefit from a larger talent pool, and this method is suitable for the interval model, but I don't recommend trying to automate in the same sprint with a distributed team. The disadvantages are there's a higher cost of communication. So there'll be no informal communication. There'll be nothing established walking out of a meeting or at the lunchroom. And you're going to need to formalize communication. So you're going to need to record a lot more detail about how something works or how it's supposed to work than you would with a co-located team. Because if you factor in the cost of communication and time zone challenges, you could have a lot of downtime waiting to find out exactly how something's supposed to work if you don't have immediate access to a developer. How many of you guys are working with distributed teams? So quite a few. Do you agree with those points? That there's a higher cost of communication? Okay. Finally, I want to talk a little bit about assessing tools for Agile automation. Record and playback tools. How many of you guys have had experience with record and playback automation? Okay, quite a few. On a long-term basis, how many of you had successful automation that was record and playback? It was based on record and playback. So I'm not going to talk anymore about record and playback automation. So I will say one other thing, though. With respect to the parallel versus the interval model, how are you going to record testing a feature if you don't have the feature yet? So you would absolutely be able to get nothing done until development gave you that feature. Tools that depend on a repository for the same reason. You can't use an object SPI to identify something that doesn't exist. Okay, so some repositories let you define things that don't exist, but if that requires a level of skill that may or may not exist in your team. So using a repository will also limit your ability to automate using the parallel model. Tools that generate unmanageable heaps of code. Some tools are better at writing code and exposing things than others. Oh, yeah, sorry.
All right, back up just a second. Can you explain what you mean when you talk about repository?
Yeah, thank you. With respect to automation software, many of the commercial tools have something that they call a repository. What this is, it's a map of all of the objects within your application. So, and different tools have different ways of identifying objects, and some of them are proprietary, but they all, not all, most commercial tools have a way of storing that information so that when you click on something, it associates it with that particular object in the repository. And that's just a way for the software to know what it's interacting with. And when things change in the software, it requires for that repository to be updated because how it's identified may have changed. So a repository also introduces a great deal of maintenance. And the alternative to that is dynamically identifying objects. So identifying them based on some property of them that is not proprietary, that's exposed. So in the case of HTML, for example, many HTML tags have an ID tag. They may have text that's unique to them on that page. There's a number of different ways you can identify them, but that's external to the software and not dependent upon a repository. So that would let you change how you're identifying an object or identify a new object before it exists, excuse me. Does that answer your question?
I think so. So you're saying it's essentially a basis for locking things?
The repository is, it's a map of all the elements that currently exist in the software. So it's the opposite of being able to fake it. It's saying I can only interact with things that the software has already interacted with. Thank you for the question. So yeah, unmanageable heaps of code. If something breaks and you need to fix it, the more code that you have to sort through to do that, the longer it's going to take you. And frankly, the lower chance of success you're going to have in doing that. Avoid 100% homegrown tools. Now, I like to write code and I like to build tools for automation, but if I'm doing that for team A and then I go to work with team B, I've created this dependency. And these two teams are going to fight. And I can give you a specific example without getting too specific about a company I worked with, where they had a developer who was working with the test team, and he was brilliant, and he created a really cool automation tool that they were using, they were dependent upon for all their tests for a piece of time and billing software that sells for millions of dollars, has tons of features. They built all their tests on this. They used this tool that he developed, which was, like I said, it had potential to be a commercial tool. It was that good, but he moved on to another team, and he started building another really cool tool for that team. And unbeknownst to anyone, product management decided to use some Silverlight controls in this web application for some key functionality. And that just completely broke his tool. Now, they couldn't get his time, and they couldn't go out into the market and find someone that could fix this. So they were dead in the water. There's nothing they could do with that tool. So they had leveraged hundreds and hundreds of hours and thousands of test cases on a system that had a single point of failure. So that's, although I like homegrown tools, it's not a great strategy. Unless you need to do it, unless there's no other thing because of the technology you're working with, you have to build something that will work with it. What I like to see are tools that support coded automation, and that goes back to your question on repository. So coded automation is basically being able to define how we're going to find and interact with an object or an element in the application under test without it being there yet, but knowing that it's going to have an ID tag or it's going to be named this particular thing if it's a Windows Forms application. Specialized tools that are good at a very specific type of testing. So the tools vendors will tell you that my tool does everything. It does mobile, does web, does Windows Forms. It can do everything. It can do API testing. It does everything you need it to do. But it probably doesn't do them very well. It may be good at some things, not good at others. I like to look at tools that are very good at doing what they're meant to do. One of the requirements there is that they integrate well with other tools and with frameworks. And that's the last point. Tools that integrate well into other frameworks or project tracking software. And testability. So I worked with a really brilliant development manager in the States, and they got budget for like a $500,000 budget to completely rebuild the GUI for their tool, the front end, and it was all web-based. And to his credit, he asked me early on, what do you need from a testing perspective from this project? I said, it was a web-based, and I said, I need a unique ID on every web element that I could potentially interact with. Anything where there's a value that I need to check or some control that I'll need to interact with. And he said, okay, great, we'll put that in the requirements. Talked to the vendor about it. They agreed, they'd done that before, no problem. So it was a 9-month project, check in 3 months. How are we doing on those IDs? Well, they're not there yet, but they're still on the priority list. Okay, check in a little while later. Oh, we're fighting some major issues here. We can't get to that yet, but it's still on the radar. And you guys can probably imagine where this is going. The IDs on those controls just kept getting deprioritized, and where the vendors taking us out for this wonderful meal to celebrate their fantastic success, delivering this awesome GUI to us. And I'm sitting there feeling sorry for myself because there's no IDs in anything. And I know that just because of the way that framework is designed, that without those IDs, our automation effort is going to be extremely challenged. That, combined with the software that was chosen, meant that our chance of success in automation was going to be really low. And we needed automation to work in order to deliver that project on time. So this led to, and I'm sure that no one here has ever had a difference of opinion with the development manager, but I did. And like I said, really got a lot of respect for the guy, but we were basically yelling at each other over this on the phone because he was blaming me, saying your automation doesn't work. You didn't deliver. You didn't give me what I needed. And his quote was, "We build our software to meet our customers' needs, not the needs of our test team." Has anyone ever heard anything like that before? So I was kind of happy when he said it, because I felt like he had made a misstep. So we make software to, in this case, it's a commercial company. We make it to make money, right? And if we have to test, if our test cycle is quadrupled because we couldn't automate, and we're going to miss a date that's potentially tied to a contract, we're not going to make money. And that was the bottom line. Right? We needed to be able to hit a date to get our contract to make some money, and we weren't going to do it in this case. And what it really illustrated for me was that his view of this process is development to customer, and there's no room for test in there. He was just sort of pandering, saying, "What do you need? What do you need from this?" He was asking the question without any real commitment to being able to deliver or any understanding. So we both hung up thinking we'd won the argument, but I like to present this in front of QA people because I feel like it validates that I win. So with respect to testability, what is it? And I don't know if you can read that in the back, so I'll read it to you. It's the degree to which a software artifact, a software system, module, requirements, or design document supports testing in a given context. This is something that we talk about all the time, right? Like, what's a good requirement? What's good acceptance criteria? Can I test it? But with respect to automation, it's not just can I test it, but like, can I even interact with it? If I don't get what I need from development or from their choices in technology, then I may not be able to automate that. Or I may be able to automate it, but in a way that will never really benefit us long term. I may be constantly trying to fix the automation, so I may never really reach any kind of economy with the efforts I put in there. So the way to look at it in terms of automation is as testability goes down, automation costs go up, and they go up quickly. And when you factor in that in a lot of cases, testability is something, with respect to HTML, for example, that would take developers very little time to add in, then it becomes a really important consideration with respect to automation in general. And I've included it because in Agile automation, we should have more access to development. They should share our pain, and they should see that. So it is a consideration. So, summary, we talked about the different models, parallel or interval, the different considerations around Agile for the automation team, internal, external, hybrid, co-located or distributed, and I hope I illustrated some of the important points around all those choices. Automation tools, tools that say they can do everything, or tools that are very specialized. and recorded playback versus the concept of coded automation. And finally, testability. The needs of the customer versus the needs of test. From my perspective, the needs of test and the needs of the customer line up perfectly, but that may not be the perspective of development. Yes?
Did the project ship in 9 months?
I was pretty close with, it was a distributed team, but I was pretty close with a lot of the stakeholders, and I'm still getting emails about the project.
So not as much.
No, it didn't ship. It demos well, but it didn't ship, and it really turned into a bit of a nightmare. There was an entire dev team that unplugged themselves from that whole. They just got so fed up with. There was politics involved, but it was after I left, and I was glad I wasn't around for it. Any other questions or any points that you guys would like to discuss further? Yes.
Check an assumption first. At the beginning, when you took the parallel interval, like your team sort of stating that the test automation is going to be done by testers or another team. Can you consider another model, like an inline model, where most teams have more developers than they have testers? You actually get the devs to automate some of the testing.
Yeah.
And do it inline, so ADV or BDV.
Yeah. And I don't know if you guys are familiar with SDETs or software development engineers in test, but it's someone with a developer work set or a toolsmith, depending on whose presentation you're reading, that has the ability to write these tests and works sort of in between. In a parallel model, you sort of need that. You need to have someone there that can do that work. What I find, though, with respect to having a developer as someone who is an automation resource, I've seen it happen over and over again, that when you're pressed for time and there's features that need to be implemented, all of a sudden that guy who's supposed to be building test tools and test automation all of a sudden is working on a feature because he has that skill set. But to your point, that is definitely a possibility, and if it's managed correctly, you can have success with that. There's another question back there.
Yeah, you talked about some test tools that you like, you don't like, but you didn't give any specific examples.
Yeah. I guess my question back would be, what technology are you interested in automating? Is it web-based? Is it Windows Forms? Is it some API? All the above?
Variety, not so much like our product.
Full disclosure, PQA is a Ranorex partner, but that tool really impresses me for a number of reasons for both web and Windows Form automation. It uses I guess a flexible way of identifying objects that you can actually build logic into, so that one script can support different platforms and different versions.
We're working on Macs.
Pardon?
We are working on Macs.
Oh, sorry.
Not Macs.
Oh, okay. So that's not supported. Yeah, I don't have a lot of experience automating on that platform. Open source tools, though, are all supporting Mac, or most of them do. So Selenium for web, and I don't have anything off the top of my head for forms based on Mac, but I'm sure there's things out there. Any other questions?
I'm just curious if you could agree with the statement that test automation is development.
Sorry, I missed the last part.
Would you agree with the statement that test automation is a development activity?
Yeah, I do, 100%. And in a completely separate presentation, I talk about how the tools around test automation and the methodology have all moved forward in the last 10 years, but the idea of treating it like a development project hasn't. So you would never run a development project in a way that a lot of teams that have, the development teams are running a QA automation project. Like, go automate this and let us know how it goes. Or, you know, they don't implement any source control, or they don't do any planning, they just start automating. And I've seen some really, well, I've seen a lot of wasted effort because they don't treat it that way. Yes?
You were saying about outsourcing your testing might not be a good idea. Would you say that in the case of something like testing a web service API, which is strictly defined, that actually would work well if you did outsource that?
Yeah, so there's definitely things around technology that are considerations. And just, I think that outsourcing isn't a great idea depending on the model you've adopted, but it can be of extreme benefit. But what you're saying, I think, is that if you're using an API that has a clear spec, then yeah, you could get someone else to do that work. There'd be a lot less interaction needed, and I've seen really successful automation efforts around that were outsourced around APIs. Okay, well, thank you guys very much. I really enjoyed this. I appreciate the questions, and